Implicit differentiations. The implicit differentiations are combined the topics for the equation of derivative in the chain rule. In the chain rule, using the notation dy over dx, let y which is equal to f of u and u which is equal to g of x, then y which is equal to f of g of x. dy over du must be f derivative at u, and du over dx must be g of x of g derivative at x. dy over dx must be d over dx. F of g of x must be f derivative at g of x, and g of derivative at x, f derivative at u. dy over dx, which is equals to dy over du times dy over dx. Practical examples on chain rule. Find the derivative of each of the following functions with respect to x. Y which is equal to 3x plus 4 to the power of 6. We got it here. Y must be, let's u which is equals to 3x plus 4, and the y u the power of 6. du over dx must be determined by 3x. When we derivate, it's become 3 at a constant. And dy over du must be, if it is u the power of 6, let's derivate it, 6u the power of 5. Now let's use the dy over dx which equals to dy over du times du over dx multiplied by them. 6u the power of 5 times 3 must be 18u the power of 5. Now we have identified the chain rule of the 18u the power of 5. U is substituting with the given function 18 times 3x the plus 4 to the power of 5. What about this one? Practical examples on chain rule by using the cos the power of 6x. Let u must be cos x, and then y which is equal to u the power of 6. dy over du must be 6u the power of 5, and du over dx must be minus sine x. Then let's use the chain rule. dy over dx which equals to dy over du times du over dx. Then 6u, we got the derivative, 6u the power of 5 times minus sine x. Now we have identified the chain rule. Now let's substitute the known value for u, cos x, minus 6 sine x times cos the power of 5x. Here is the derivative of some functions. We can simplify by using the derivative works for the functions, identifying by power function. Like this, f of x equals to x the power of n. Let's derivate it. F derivative at x must be nx the power of n minus 1 by using the proof and also the theorem. Second, by using the negative integers of the power function, it must be negative. F of x equals to x the power of minus n. F prime x must be minus nx the power of minus n minus 1. Practical examples on derivatives. Now find the derivatives of each of the following functions. For x squared, x the power of 6 to x the power of 9. The correct derivative here like this. If the f of x must be 4x the power of 2, then let's derivate it. It becomes 8x. F of x equals to x the power of 6. If we derivate it like this, 6x the power of 5. But on the last theorem, we can give also, if we can derivate like f of x which equals to 2x the power of 9, then f prime x must be 18x. This is the most important equation which we are familiar with, the appreciations of the equation by using the derivatives and their implicit differentiations. Thanks for listening.